Hello everybody. I'm going to go through these notes fairly quickly because they can be easily rewound, paused, and rewatched. But we talk about conjectures, counterexamples, inductive and deductive reasoning. Inductive reasoning, we are looking at a number of examples to arrive to a conclusion. The best way to look at it is to notice what your pattern is. So we are observing a pattern and it continues to apply inductive reasoning, and then you make conjectures. So like if a person was tardy every single day, so that I know I can conclude that they're going to probably be tardy today as well. When we talk about conjectures, conjecture is a statement based on an observation. So a concluding statement reached using inductive reasoning, unproven statement based on observation. So it's unproven and it's based on observation, like we talked about with patterns. So if it's raining outside, therefore, what am I probably going to need? I might need an umbrella. If we talk about counterexamples, it is just you providing one example that makes a statement false. That is the biggest thing that we want to try to do. So if we have an angle that is obtuse, then its measure is exactly 100 degrees. Well, that is true, but not all the time. I can disprove it, so I'm going to say it's false. What would be a counterexample? Well, what if the measurement is 120 degrees? Is that obtuse? Yes, it is. So it's proving our statement false, but making it true at the same time. Deductive reasoning uses facts, rules, definitions, or properties. So anything that is thrown up, it will always calm down. How do we know that? We look at the law of gravity. So we're going to say deductive reasoning. And we'll get that later with the key points that make the difference between deductive and inductive. So if we just want to make conjectures, we can look at a pattern and then we can guess what's going to come next in our sequence. So if I notice 20, 18, 16, 14, what is this doing? It is going down by 2 every single time. So if I want to guess the next number, I know that down 2 from 14 would be 12. So that is my next number of my sequence. Here we have suns drawn, and my pattern is I am adding 1 to the top, and then I'm adding 2 to the bottom. If you notice, I added 1 more to the top, and then I added 2 more to the bottom. So if I wanted to draw this again, I would have 4 dots total on the left side, and then including the one that we start at, I would have 1, 2, 3, 4, 5, 6, 7 dots total on the bottom. Continue in my pattern. Here I have a cross and it's got a block shaded in, and the first image is at the top and the second one is on the left side and then on the bottom. So what am I doing? I am rotating 90 degrees every single time. So I take 1 quarter turn, 1 quarter turn. So I know that my next movement is going to be located on the right side of my figure. So I can draw my figure and guess what's going to come next. With our next little portion, we are going to skip this. You aren't going to see this pop up, so we can go into having statements. So if we read a statement, we want to see if we can provide a counterexample. And the only way we can do that is if we say the statement is false. If we say the statement is true, no counterexample is being able to be made. So if an animal is a bird, then it can fly. Well, yeah, that's true, but is an animal being a bird the only thing that can fly? What about a penguin? Right? A penguin is not a bird. Or, sorry, a penguin is a bird and it can't fly. So when we do this, we are saying false. And what is our example to disprove this? Well, we said a penguin. It's a bird, but it can't fly. If a number is even, then it is divisible by 2 only. Alright, so we know that it is going to be false. Why? Because I can disprove it. Let's take the number 16 and let's divide it by 4. Alright, 16 is an even number, and if I divide it by 4, it comes out to be 4. So is it only divisible by 2? No, it is not. So I'm going to say my statement is false, and me proving it with math is my counterexample. If a polygon has 3 sides, then it is a triangle. Well, can you name any other shape besides a triangle that has only 3 sides? Well, no, you cannot. So we are going to say this statement is 100% true. We cannot provide a counterexample. So if we cannot provide a counterexample, make sure that you leave this space blank, or put not applicable. No, I can't even say that word. It's too early in the morning here. All right. If you subtract 2 numbers, then the result is an odd number. Well, I can prove that differently. We are going to say that's false. I could take 15 and subtract 11 away from it, and I'm going to get 4. Well, I subtracted 2 numbers, and the result is an even number, so I disproved my statement. This is my counterexample, and I'm saying it's false. The last one, these are really good hypotheticals to get our mind to wrap around it. All basketball players are over 6 feet tall. Well, have you seen a basketball player that is under 6 feet tall? Yes, you have. So we are going to say that this statement is false. What could be an example? Well, our good old friend Muggsy Bogues. Everyone has probably seen him if they watch Space Jam. He's a good 5'2", and he's an example of a professional basketball player that is under 6 feet tall. Alright, I like to break up the categories of inductive and deductive reasoning. If it is inductive reasoning, I am looking at patterns or observations, and if it's deductive reasoning, I'm looking at it being a law, a rule, or I like just to use the word facts. So Jake notices that every time he throws a ball up in the air and it comes back down, he concludes that if he throws a ball up again, that it will come back down as well. A lot of us might think, oh, it's a fact because there's a law of gravity. But pay attention to our question. He notices that he throws the ball up. He didn't state anything about gravity or any rules of physics, so we cannot conclude that he is thinking this as a factual evidence. He is seeing and noticing patterns, so we are going to call this inductive reasoning. Why? Again, we said it's an observation, a pattern, or that he notices this. In the second question, Tom says Newton's law, everything that goes up must come down, so if you throw a ball, it must come down. We can say that he is using deductive reasoning because he stated Newton's law, which is a fact, and so we have a law, which is a fact. And then lastly, if 3 points A, B, C are collinear and point B lies in between points A and C, then AB plus BC equals AC. If we don't know what we're doing, I always love to draw our pattern. B is somewhere in the middle, and if I add AB, BC, it's going to equal the whole of AC. Does that work? Yes, it does. I know that I had talked about collinear points and the factual evidence of AB plus BC is equal to AC. Sorry, that's underlined. Right? So if we know that those are facts, we are going to say this is deductive reasoning. That is all for today.